Introduction. Implement methods to learn useful data representations without explicit labels, enabling downstream tasks with minimal supervision. In this session, you will discover techniques to extract meaningful features from unlabeled data, improving model learning efficiency. Understanding representation learning. Representation learning transforms raw data into informative features automatically. It helps models capture important patterns without relying on labeled examples, which are often costly or unavailable. Importance of unsupervised learning. Unlike supervised learning, unsupervised methods find structure in data without explicit labels. This enables leveraging large unlabeled datasets to build strong feature representations. Common techniques for representation learning. Popular methods include autoencoders, principal component analysis, and contrastive learning. Each approach extracts compact, useful data summaries that improve performance on tasks like classification or clustering. Building representation learning models step by step. 1. Select an appropriate unsupervised technique suited to your data type and problem. 2. Train the model to encode raw inputs into compact feature representations. 3. Evaluate learned features by applying them to downstream tasks with minimal labeled data. Applying representation learning in practice. For images, autoencoders can compress and reconstruct data, highlighting essential visual features. For text, embedding models capture semantic meanings without labeled corpora. These representations improve efficiency and accuracy in subsequent models. Benefits of minimal supervision. Representation learning reduces the dependency on large, labeled datasets. This is valuable in fields like healthcare or finance, where labeling is expensive or sensitive. Validating learned representations. Test representation quality by measuring performance gains on downstream tasks. Use clustering accuracy, classification scores, or visualization techniques to assess feature usefulness. Iterative improvement and tuning. Experiment with different architectures and hyperparameters. Incorporate domain knowledge to guide model design and interpret results effectively. Challenges and mitigation. Unsupervised methods may capture noise or irrelevant patterns. Careful tuning, validation, and combining with supervised learning can improve outcomes. Reflecting on your experience, consider tasks with limited labeled data. Could representation learning have enhanced model performance or reduced labeling effort? Best practices for representation learning. Choose methods aligned with your data and goals. Visualize learned features to gain insights. Combine unsupervised learning with supervised fine-tuning when possible. Tips for prompting Gen AI. Ask for specific techniques or architectures. For example, say, suggest an autoencoder setup for learning representations from sensor data. Clear prompts yield targeted and useful advice. Conclusion. Representation learning enables effective feature extraction without explicit labels. This approach expands your ability to use unlabeled data for diverse applications. Thank you for joining this session. Start leveraging unsupervised learning methods to build stronger, more flexible models today.